Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Ahmad Iqbal Rafiki bin Syed Muhammad Syahran and my matching number is DE220171. So now I'm going to present about our group introduction. So first is soft RTOS for multimedia support. The need for the need for soft RTOS is multimedia tasks like video streaming and gaming require strict timing to ensure smooth playback and quality of service or QoS. So the core objective is soft RTOS meets timing requirements with high probability to balance system timeliness and throughput. So the key techniques is the first one is scheduling. Use priority-based assignments for time-critical tasks or earliest deadline first, EDF, for periodic frames. The second technique is resource management. Employ CPU reservation to prevent resource monopoly and double buffering to minimize playback interruptions. So the third technique is synchronization. So it is utilize high resolution timers and timestamps to keep audio and video streams perfectly aligned. So the outcome for this for our assignment is these mechanisms provide the predictable environment necessary for high quality multimedia performance. That's all for me. Thank you.
Assalamualaikum, my name is Muhammad Amir Fahmi, and I will explain for the background and scope. So, for the first one is the early origins. The history of real-time operating system, which is RTOS, traces back to the late 1940s and the 1950s. And then for the military projects, some of the earliest developments were driven by critical military applications, specifically the Whirlwind and Flight Simulator and the Siege Air Defense System. And then defining the timing, where this system were created for environments where the data validity depended on both the accuracy of the result and the exact time it was produced. And then commercial milestone in the 1960s, IBM produced the first commercial real-time operating system, which was known as Basic Executive. And then modern evolution. This laid the foundation for systems like VxWorks and QNX that emerged in the 1980s and 1990s. Moving on to the classification of RTOS, operating systems are currently classified by the impact classification criteria. So today, operating systems are classified based on the consequence that occur if a specific time deadline is missed. And then hard real-time system, where the system are required strict deterministic behavior at all times. And then severe consequence. In a hard system, missing just one deadline can lead to the catastrophic system failure or even life-threatening situations. Now for the scope of supporting multimedia. So for the first one, soft real-time system. Unlike a hard system, soft real-time system focus on meeting deadline with a high statistical probability. And then for the performance impact, if a deadline is missed in a soft system, it leads to performance degradation rather than a total crash. And the multimedia example, a practical example of this degradation is a drop or miss video frame, which is why soft RTOS are ideal for multimedia application where a slight glitch is not catastrophic. And last but not least, project focus. Therefore, the scope of this project is to analyze the scheduling strategies and resource management techniques required specifically for video and audio playback.
Okay, for the classification of techniques, the multimedia application need timely processing to avoid lag and glitches. And the second point is the soft real-time operating system, as known as RTOS, aim to meet deadlines with high probability. And then it focus on maintaining smooth playback and quality of service. Which is the acronym is QoS. Okay, one of the technique is named real time scheduling. The the first point is the scheduling decide which task run first on the CPU, and then it choose the important for the multimedia tasks like audio playback and video recording. And the last point is soft RTOS use special scheduling methods to reduce delays, and also the goal of the technique is to to give us the balanced fast response and system performance. Okay, for the another alternative method for the technique is the priority based scheduling. Okay, each task is given a priority level. The higher priority tasks run before lower priority tasks, and then the multimedia tasks, which are the audio and video, are given higher priority. By using this method, it helps us to reduce the audio delay and video stuttering. This method also simple and effective. However, it also comes with downs, which is wrong priority settings can cause priority inversion. And beside of the point is the diagram. It's a figure that explains a little bit about the priority based scheduling. And what comes next is the deadline based scheduling, which known as EDF. Okay, so the tasks are scheduled based on their deadline. The task with the earliest deadline run first, and then the suitable for video. Okay, for this method, it's very suitable for video frames and periodic multimedia tasks. Okay, so the advantages of this method is it use the CPU usage very efficiently, and then the cons of this method is it is more complex to implement to multimedia software. And then the afterword for the technique is the resource management techniques. Okay, for this technique, certain multimedia application need CPU, memory, and input and output bandwidth, and also the poor 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 resource control can cause frame drops and playback interruption, and also it solve the RTOS manage resource to ensure stable performance. And then the next part is the CPU reservation and bandwidth control. For this method, it guarantees us the fixed portion of CPU time for multimedia tasks. It also prevents other tasks from disturbing playback. For example, the constant bandwidth server. For example, the method can be seen inside the constant bandwidth servers, also known as CBS. So benefit for this method is it can smooth the multimedia performance, and also it can provide better system stability under heavy load. Okay, for the latter part is the memory and input and output management. Okay, for this method, this multimedia the multimedia data requires fast memory and data transfer, and also this technique use the buffer management and direct memory access DMA for uh, for a single buffering management. And for the double buffering management, one buffer process the data, and then the another buffer loads some new data. As you can see, there is a example for figure. There is a figure example on the slide, and then this method can reduce delay and interruption. And then comes the timing and synchronization mechanism. Okay, for the this mechanism, it's very accurate timing. I mean, okay, for in every multimedia software, accurate timing is very critical and crucial points to look for because uh, this multimedia because the multimedia needs very perfected audio and video synchronization, smooth playback, soft RTOS use timing control to keep media streams aligned with each other, with each of the video and audio. Okay, as you can see, as you can remember, that in every multimedia there is sort of timer and clock. Uh, usually insert or put at the below of the screen, bottom screen. Okay, for the clock management and timers, it use high resolution timers. With this method, it ensures tasks run at correct time intervals. However, this relies on monotonic clocks peri- and periodic timers. Um, and also, this method helps maintain consistent frame and audio timing. Okay, for the inside of the method that we that we that I have explained before, the audio and video synchronization, it ensures sound. It making sure the sound match match the video and video display. It use timestamp based synchronization, and also audio and video share a common clock. For this method, maybe there is probably very slightly unnoticeable small delays are allowed. However, the small delays are allowed as long as the user experience is not affected by the delays. And then the next part is I will leave the rest to my group mates.
So, the admission control unit is responsible for deciding whether a new multimedia task, such as video or audio playback, can be accepted into the system. It checks system resource like CPU usage and memory availability. If enough resources are available, the task is accepted. If not, the task is rejected or delayed to prevent the system overload. This helps ensure that exciting multimedia tasks continue to meet their timing requirement and maintain the quality of service. For slide 16, this slide explains admission control technique. Admission control is used to decide whether new multimedia tasks such as video or audio streams can be accepted into the system. Its main purpose is to prevent system overload in soft real operating system. By limiting the number of active tasks, the system ensures that existing multimedia tasks can still meet their timing constraint. This helps to maintain the quality of service or QoS, especially for applications like video streaming and online media playback. So next is synchronization and concurrency control technique. Okay, so for the synchronization and concurrency control technique, it is used to manage access to shared resources in real-time system. They prevent issues such as race condition and priority inversion. Technique like priority inheritance and priority ceiling ensure high priority multimedia tasks are not blocked by lower priority tasks. Proper synchronization timing, predictability, and ensure smooth audio and video playback.
So next is discussion. Unlike hard RTOS, soft RTOS focus on meeting deadlines with high statistical probability. Occasional misses are acceptable to maintain system flexibility, making them perfect for video, streaming, and gaming. Some key technical pillars of these are dynamic scheduling, EDF, earliest deadline first, prioritize tasks based on the proximity of their deadline. Second, priority based ensures critical media streams take precedence over background processes. Next is resource management. The CPU reservation part guaranteed processing cycles for jitter-free playback, while double buffering prevents frame tearing by rendering one frame while displaying another. Next is synchronization. High resolution timers and time stamping to keep audio and video in perfect syncs. So here are some key examples between hard and soft RTOS. Next part is a discussion about sustainability and future research. So firstly, about future research, HAI and soft RTOS, it includes low latency scheduling for HAI, extends soft RTOS scheduling like hybrid ADF to support ultra low latency requirements, informed by automotive edge like self-driving car and live demo, which needs a response within milliseconds to be effective. Next is dynamic resource management, which integrate workload prediction and CPU reservation techniques aligned with edge constraints due to limited SOC, compute and energy to support real-time tasks in decentralized systems. Next is advanced buffering for edge network. Compare traditional double buffering with asynchronous edge buffering to reduce glitches where real-time streams interact with variable network. And finally, scalable synchronization for distributed environments. Pilot refined synchronization mechanisms that account for mixed cloud or edge execution and multi-stream VR AI tasks, reflecting hybrid processing trends in automotive and edge AI platforms. In conclusion, this report highlights the key foundation of modern multimedia systems, focusing on specialized scheduling, efficient resource management, and accurate synchronization. Soft RTOS principles play a crucial role in maintaining consistent quality of service by balancing timing requirements with system throughput through techniques such as priority-based scheduling and double buffering. While hard real-time systems remain critical for safety-sensitive applications, soft RTOS architectures provide the flexibility needed to support the continued growth of interactive and immersive digital media technologies. That's all from us. Thank you.